All right, what is up, everyone? Hello, and welcome back to another lesson of Nick Does Algos. And in this question, we'll be covering the Hackerrank easy rated algorithm, Manasa and Stones. And I've got to admit, this question is worded really, really poorly, but we'll break it down, we'll start to understand it, and then we'll get to work. So in this scenario, Manasa has two different kinds of stones, and you are provided a certain number of stones that you have. In this case, you've got two stones, and your type A has a value of 2, and your type B stone has a value of 3. And this question wants you to find all the different possible sums of combinations of your two stones that give you two stones. So if this number were 3, then you would look at all the different combinations you can make of 3 stones using your 2 stones. So in this example with 2, you can have the combination of stone A and stone A, stone A and stone B and stone A, or stone B and stone B. Basically all the different ways you can put A and B together to make a string with a length of 2. But if you look at the, okay, so first we'll go over the issue with this problem. This example specifically, they tell us that you start with stone 0 no matter what. You will start with a stone that has a 0 value to it. So essentially this n should really be 3, and each of these arrays should have a 0 at the beginning. Just a weird little caveat. If you go down to the examples down here, you'll see, check out this explanation. You've got n equals 3, and you start with the 0 stone every time. Really weird little caveat to this question, but not to worry. But so what you're really trying to do is find all the different permutations of the stones that you can have for the length of n, and then find the sum of those stones and return that at the end. But if you have multiple sums that repeat, you want to get rid of those. So say you had 2 different permutations that added up to the sum of 30, you would just input 30. And they explain that here. So this scenario, they also do this oddly. This is the running sum. So in this first example, you've got n equals 4. So you will have 4 stones. Your first stone will always be that stone with the value 0. And then these 3 stones are all 10 stones. So your running sum goes to 10 because you've got a stone that's worth 10. Your running sum goes to 20 because you've got a stone that's worth 10 added to that. And then your running sum becomes 30 because you've got a stone of 10 that's added to your sum of 20. So kind of funky. And then here's another example. You've got the combination of stone A, which is 10, stone A, which is 10, and then stone B, which is 100 to give you 120. And then you see that if you flip-flop these last 2 stones, if you flip-flop this 10 and this 100, well, that gives you another permutation, but it gives you another permutation with the same sum as what you did for the second one. So let's head over to Replit and start to get to work and walk through some of the logic here. So you know you've got n. N is the number of stones you're going to have, but it's really n minus 1 what you're working with, because stone 1 will always be 0. So just keep that in mind. And then let's think of a scenario. Let's change this up a bit. Let's use 10 and 100, and let's use an n of 5. Okay, so there's a bunch of different ways to put A and B together, right? So you will have a sequence of 5 stones, but the first one will always be 0. So our first example would be 4 A stones and 1 0 stone. But we're just going to go ahead and neglect the 0. We're just going to treat n as 4 and look at the A stones. So here's your first possible combination or permutation, right? All A's. Next one, let's go ahead and change the last stone to a B, and then you can go ahead and move that one, and then you can go ahead and move it again, and then you can go ahead and move it again. So these are all different combinations, right? These four are all different combinations, but if you look at it, they're all going to give you a sum of 130. So what's really important here, what really matters is not that you have all the different ways that A and B can be ordered together. What's important is that you look at all the different ways in which you can have A's and you can have B's. And what I mean by that is what's important is the number of A's and, oh, don't need an assertion error. The number of A's and the number of B's. That's what matters. It doesn't matter how they're organized. You're going to get the same sum no matter what. So say that we have this n of 5, and like I said, we're going to treat it as n of 4 because we can ignore the first 0 stone. And what are all the ways that you could have a string of 4 numbers or an array of 4 numbers and have different sums? Well, there's only a couple different ways to do that, right? And you can list them out pretty simply. It could be A, 4 A's, 3 A's and a B. Oh, sorry, 3 A's and a B, 2 A's, 2 B's, 1 A, 3 B's, and 4 B's. So you could have a ton of different permutations, but these, I believe, forgive me if my my algebra is off, but I believe these are the combinations. What you care about is the combinations, not the permutations. Position does not matter. So this string where you have 1b would be equal to this. You just move the b. The b's in a different position. So that bit of info that you're provided here is pretty superfluous. You don't really care about the position, because all we're looking for is sums, and not only that, but we're looking for unique sums. Okay, so this is what essentially we're looking for. We want to find the sums of these 5 different combinations. But so how can we build this out programmatically? So let's first go ahead and initiate a variable that will hold our totals. Let's call it totes. And as we find the unique sum of our combinations, we will add that to our totals array, and then we'll go ahead and append that at the end. And like I said, we don't really care that n is 5. N that we're going to work with is really 4. So we can just go ahead and do n equals n minus 1 to get things started off. Okay, and then we're going to want to do a loop. And the reason we're going to want to do a loop is because we could start out with a scenario in a range loop where we create this combination by setting a variable like I that's going to iterate. We'll set that equal to the b's that we have. So on our first loop, that would mean that we would have 0 b's. And then how could we say that we have 4 a's? Well, you can take n and subtract I from it. So on this first loop, that would mean that you've got 0 b's and 4 a's. Because you're taking n, you're subtracting 0 because I will be 0. And then I will go up 1. That means that your n minus I will go down 1. You would add a b and subtract an a, and then the same thing would happen here, and the same thing would happen here, and the same thing would happen here. So let's go ahead and build that out. Like I said, that's a simple range loop we'll do for I in range. And what's our range going to be? Well, what we actually need to do is add 1 back to our n, which is kind of funky, but that's just because of how range loops work. We want to include n, even though we just subtracted 1 from n. It's kind of funky to look at, but it makes sense. Okay, so then what would we do? What are the variables I just mentioned, or that we need to manipulate and then add to find the sum to add to totals? Well, what would we first do for A? In this scenario, we want 4 A's and 0 B's. So you would do n minus I, right? Because n is equal to 4. 4 is what you're starting with. And I is equal to 0. And then you're going to multiply that by A. And let's just parenthesis all of this off. And then we will add that to what our B value will be for this part of the loop, which is simply B times I. Let's just go ahead and print this. I'm not going to add anything to our totals array yet. Let's just print as we loop through the array. Okay, yeah, let's get rid of all this. Hopefully you're following. If not, you can pop back in the video and copy and paste this over. Or sorry, transpose it over. Okay, what just happened? What did we print? Oh, we printed, first of all, incorrectly. Okay, there we go. So we printed our 4 A's, our 3 A's and a B, our 2 A's, 2 B's, our 3 B's and an A, and our 4 B's. So there you go. That is really the bulk of it. That's the logic to get the sums of the variables. And instead of using print, you would just do totes.append. And then at the end, you would return. You do have to sort. I think we use sorted. Sorted totes. Simply that's because what the question asks for, it wants you to return the unique totals in a ascending order. But there's one thing we didn't account for in this method. We didn't account for repeats. So what does that mean? There was a scenario where A and B were both equal. So you could see how this would cause a problem, because if you did 4 25s in all the different combinations you could get with A's and B's, well, the total's always going to be the same. So a way around that is just to create a conditional statement. So you could do that by saying if I equals 0, you will do this no matter what. You will find that first thing to add to your totals. And then else, if I is greater than 0, if I is greater than 0, and you get a unique value, you get a value that is different than the last value that you just added to your totals, because that's what's important, right? In this scenario with the 25 and 25, you would just keep appending the same sum over and over again. But instead of that, we're going to append the first one, and then we're going to look back in our array and say, is that value, that last value that exists in our array, is that different from what we're about to put in there again? If it is different, we will put that next value in. If it's not different, we will not put that next value in. So if I is greater than 0, and this is kind of lengthy, but how are you going to look back to the last thing you put in your totals array? Well, that would be totes, and then you would go into the position in totes, and how would you access that? It would be length of totes minus 1. And that's just to check to see what that value is, that last position. And you would say, if that is not equal to our current value, which is this same code we wrote here, then I think I've got a syntax error there, maybe not. Then we will do the same thing. We will append that new value that we just calculated, that new sum of that combination. So let's go ahead and print again. just to make sure our syntax is lined up, I might just copy and paste over to Hackerrank from my VS Code. I almost always wind up with a small syntactical error that screws me over. Um, let's get rid of that, see if that's causing an issue. And oh, we have lost inner. Okay, there we go. So this works. Those are the 5 values that we were looking for. And I will copy and paste over from my VS Code just because I am superstitious. So here you go. Let's paste it over. That should be the same as everything we just wrote in Replit. So let's go ahead and run it. Make sure it checks out. There you go. We pass both of our sample test cases, and then we run that against all the test cases, and we pass all of them. So there you go. I hope that makes sense. I hope it is clear. It's simple enough. I'm sure if you start taking notes, if you start printing multiple variables, the variables that you're working with here, it'll start to come together. If you like this video, if it helped you out, please go ahead and hit the like button. If you wound up having any trouble or have any questions, please feel free to drop them down in the comments below. If you are at a point where you are covering algorithms, if you're studying algorithms, getting ready for interviews or anything, go ahead and hit the subscribe button. We put up new videos just about daily, and I'm sure we will be able to help you out again sometime in the future. Thanks so much for watching, and we'll see you in the next one.